Okay, so I think we can start then the next session. Just let me start and share my screen. Okay. My technical team, can you confirm it's all still fine with okay, even with the warning? Okay, so also okay, I think I'm sharing the screen, so we are all set up. So nice to it's my pleasure to welcome you. My name is Łukasz Krainski. I will lead the next session on advanced predictive modeling. So let's start with repository again, and all the materials that you need are in the okay, yeah, I think that's that would be sufficient, I hope. So we will use the materials in day 2B. So we have a Jupyter notebook, few images in the image folder that are embedded in the notebook, and a data set that we will use, and also the description for the data set. So before we start with the notebook, let's go through the teaching objectives and the agenda for the upcoming 2 hours, or almost 2 hours. So the session, this course will be revolving around machine learning. So let's start with machine learning process, machine learning life cycle. So we'll go through the steps of this process and familiarize ourselves with that. To let's say, so let's treat it as theory for the upcoming practical part of the exercise. Yes, and our main piece of software today, or a framework, it will be MLJ, so machine learning in Julia. This is basically how this abbreviation is resolved. So this is a machine learning framework in Julia also. So this will be our main topic. And basically, we will go through subsequent steps of the machine learning process with using this framework. So we'll start with the data preprocessing. Then we will explore the models that are compatible with MLJ. So this is, I would say, quite interesting part of this framework. That also the framework is a repository of models. We will see how to operate with that, and how to understand how we can load the models into the notebook. After selecting few appropriate models, we'll train them and evaluate on the data that we'll load, and will, of course, the evaluation will be connected with few metrics of our choosing, and after the training, we'll focus on hyperparameter tuning and cross-validation for a specific machine learning model. That will almost conclude the session. There should be, say, one small point in the teaching objectives. It's in the agenda. So also at the end we will save the model, but this is basically part of day 4. So it will just highlight the topic, highlight how we can save the trained models, and more on that will be on day 4. So I think agenda is more or less tied to the teaching objectives. So I don't think we should go through each point. Yeah, and I think we can now start the Jupyter. So I assume that you have the repository downloaded. It's probably you already did on the previous day. So I will browse to my desktop, where I have the repository. And as usual, let's start Julia here in the main folder with the project switch. So we will activate the project. just checking if everything is here. So looks good. And I want to use iJulia with good capital letters, and let's start the notebook with the usual command from the repository. And again, I will make it a little bigger, maybe not that big, but we will see. So let's go to day2b and to MLJ notebook. Okay, so as I said, we start with the just let me make it this little window go away. So let's start with machine learning engineering. So there's engineering in here. So I think it's right now today a quite important part of machine learning. So just for my information, so those that are present in the classroom, like, do you have like, are you familiar with machine learning? And like a lot, or like just give me a, okay. So thank you for that. I just want to like make sure how much we should go into details. And I think maybe it's worth to start that basically it's quite a big process. And today we'll focus on this part from, okay, just to be honest, goal definition will be there, but this will be insignificant in our session. We'll focus on those first four boxes. So data collection and preparation, feature engineering, model training, model evaluation. I think that like if we get back like few years back, or maybe let's say it's 10 years back to be, let's say, on the safe side, like the machine learning, like there was not really engineering in that. So it works like that. Okay, it was already well established in academia, probably also on MIT. Yeah. But when it comes to the industry, to enterprises, it was more like okay, it's a hot topic. It was already data scientists were a sexy job, or however it was called back then. So I think it was mostly those four boxes, from data collection to model evaluation. Maybe even collection was a little not really so significant as right now. So basically, like there was some analyst or data scientist who was using probably Python or probably Python or R, yeah, to build some model. It took some time. There were some requirements, but in the end, like the model was not really deployed into production. So it was really good job, but not really useful in the end. So I can, yeah, there is a study that says, so it's not just my, let's say, I think subjective opinion, like that even 90% of ML projects were discarded because of some difficulties. So I think this, let's say, new diagram, because if you see this on the source, this is, by the way, really good book from Andrei Burkov, ML Engineering. This is from 2020. So let's say it's quite fresh. Yeah. There are, I think, yeah, two important parts that were missing back then. So we have a goal definition. So yes, it's important in the end. And we have this bottom line that is basically this engineering part, at least in my view, that this is more related to software engineering, to some DevOps practices. Also, DevOps is still also quite new if we are going 10 years back. So right now, I think this is more complete view, and we like, I think we are all aware that there are like successful, like machine learning is everywhere. So basically, it was deployed, it works. If you go to your like social platform of a choosing, you have like recommendations, that the content is personalized, or maybe even hyper personalized for you. I don't know, even if you go to doctor, like there is some, like, based on your history, maybe we can offer you something new. So basically, those machine learning applications are everywhere, and I think it's also like making them happen is also a part of this process that we focused on deploying the models. But yeah, let's start then with the goal definition, because actually, if the machine learning project failed back in the time, I think there were two main reasons for that. So first was related to this goal definition. So there was something done, but actually, in the end, it turned out like, yeah, some project manager came and said, okay, that's really good, but that's not what I wanted. Yeah, it's not doing what I was doing, or maybe it's not feasible from the I don't know, cost perspective or business perspective to do that. So that was one thing that the business and, let's say, data scientists view or engineers view, like, they divert. But also the second reason is that probably you made a model, it works good in your laptop or PC, and then you try to deploy it, and okay, it's working, but when you have more than 10 people using it, then it's really then we have an issue. It's not scalable, or maybe okay. Yes?
What do you mean by deploying?
Okay, so by deploying, I mean, so if when we build the model, we can use it. So we can predict. Let's say this is a prediction model. So we can make a prediction on our local machine. For me, deployment is enabling for some other people to use it. So what are other people depends on the situation, because if we are talking about social platform, I would say to make it public, the usage of it, and basically to make a service that is enabling the predictions, if this is a predictive model, to be delivered to you. Yeah, but of course, in some maybe transformed work, when this is where the software engineering comes, maybe this is the model that is deployed internally in the company. So then we are talking about coworkers, but basically deploying is making someone else able to use it. I hope this is not a strict definition, but I hope this is good enough. And so the model may fail if you So I mentioned scalability, so it's not working, or maybe you develop a model, but then your team says, okay, it's really good, but we don't have environment to put it. We like on our user-facing platform, we have only Java and then C++. So if you rewrite it to C++, we can potentially put it on, but if it's in Python, then it's not doable. So there were some silos, some frictions on this point. So a lot of course, there's a lot happening in the IT area, and we don't want to go into details today, but Sebastian will talk a little more about Docker on the day 4. So it's a technology that make those frictions go away a little, at least, and they introduce new frictions, but basically it's much easier to put those applications online. But let's keep the questions about Docker for day 4, and I think we can actually look what's happening. Also, I like that in this diagram there are the positions, like jobs, like we have business analyst and data analyst. So actually this process can't be. I feel that it can't be really well described without people doing this, and I think we can have a really nice discussion what the data analysts and data scientists mean, and also I think we can just agree that it's everyone can have a different opinion, but basically everything starts with a goal, and this is let's say a healthy project. If you have a business side, like if we go down, let's say project managers, project owners, C-level executives, so whoever from business side is interested should raise let's say a requirements or a project, initiate the project. So then it's quite important to think if there are machine learning models to accommodate that, yeah, and what are the end goals, what are the metrics, KPIs to use it. So maybe just to make an example about that. So let's say you have you are owning a social platform. Let's call it I don't know, Facebook or Twitter. It's quite important that we can post photos there. So let's make it a Facebook, yeah. So you want to like you post a photo. So like the platform knows who you are, but platform don't know the people on the photo. So you want a machine learning face recognition system to tag the people in the photo. So I think you are aware that this service is already there, and I think also on Facebook and other platforms. So this is not invisible, but you start working on that project. There is a data gathered, like it probably takes like few months or maybe a year, maybe more. Hard to tell depending on the size of the platform, but yeah. So let's say like in the middle, the project managers came. Okay, so yeah, like you have something. It's really nice. You are tagging the people, but now there's a new trend. Like you can have filters on your photo. So now we want to recognize people who wear, I don't know, bunny ears or have like a hat of a witch when there's Halloween. And okay, that's not everything. So we want also to tag people on the videos, not on the photos. And you see, so that's changing goal, and you need to frame the problem because we agreed on photos without filters, yes, and then you work on the project and the requirements are changing. So then yeah, of course, if you can accommodate the requirements, good, but if not, then it wasn't the frame of the problem, yeah. And as I said before, I think it was missing, and those goals were not actually well set in stone. But yeah, let's say we have a goal, so we need to collect the data and prepare it. Depending on the data, it can be harder or easier. So I think there was a nice example, like in 1968, 66, if I remember correctly, observations about companies was sufficient to make a econometric model. But yeah, right now if we are in the machine learning area, also Bartosz mentioned that we are talking about big data, yeah, basically. And now I just put myself on the trap. What is then big data? Where is the threshold? Yeah, okay. So I like to say if it doesn't fit into the Excel, then it's big data. Probably not really. So yeah, if you need to, like the serious let's say approach, I would say if you need to use distributed computing, then it's big data. If it doesn't fit into your memory, of course you can take a bigger PC or a computer, but we are talking about like in observations like hundreds of thousands, millions, billions. Yes, so today we will use like 50K observations, so a little more than Mateusz, how many did you generate in the synthetic data set?
100.
Oh, so yeah, that's still good for machine learning, maybe. But like a bottom line, I would say. And actually, I want to focus on the names that are here. Maybe just I can make it. So we have data engineer and data labeler. So I think the first is more clear, and also I want to touch upon what Bogumił said on day one, that okay, CSV files are great, but if we are talking about millions or billions, then those CSVs are not a way to go. We are using CSV today, but as I said, 50K is like, also I can't give a number that is sufficient, like the upper limit for CSV. But if you want to have a big data, then probably this Parquet format or something like even new, like there are the Iceberg and all other new formats that are used. So basically, they are crossing the barriers that you can use more and more data, but we are talking about something that is not CSV in practice, and this is quite hard to manage alone. So data engineers for sure take care of that. Then we have a data labeler. So that's an interesting job that was purely created for the machine learning. So do you have an idea what data labeler may do? Yes, or like
defining the label of a variable, target variable. So, for example, stating whether this is a dog or a cat.
That's exactly the example I wanted to give. So if you have a pictures of a dog and a cat, and you don't know which is dog and the cat, so people are sending. So you need someone who will mark it. Yes, so that's a data labeler job, and actually it's a it's a big problem. So if you have supervised problem, so like is it a dog or a cat? So we have a target label, because we will touch really slightly on unsupervised learning like clustering. But if you have data coming and you don't have labels, this is really a big cost for you to actually label them. And like there are the services in the cloud that you can send your data, and some people will mark it for you. And then this is a interesting job, to be honest, and this is just a proof that this is actually happening. If you are investing in labeling, then you probably have a good goal and a project. And then we have something more standard. So let's say we have feature engineering. So making new variables, new features that your model may need. So deriving the longitude and latitude from the coordinates, like a simple transformations. Maybe there is something more interesting, like I don't know, enhancing the data in the sense that you are using other source to, for example, attach the weather data to the time you have in the observations. Or maybe if you have if you are working on the, let's say, people data, then you can make some news screening, if this is allowed, of course, and some other operations. And then we have model training and evaluation. This is quite closely connected, and we will do it a lot today. I think that's the main part of the notebook. And here we have a data analyst doing this. Probably some of you will say this is not a data analyst job. I mean, then I'm coming back to our discussion. What actually the people in the process are named. So I think project managers, product owners, that's quite clear. Yeah, business side. Then we have data engineers. Okay, I broke my markdown. So we have data engineers. I think it's also quite clear. Basically, if you turning CSV into Parquet, of course that's oversimplification by a lot, but skilled people who know how to handle storage and workflows like in the cloud and on premise, whatever you need. So this is kind of a bottleneck a lot, I think. Also depending on the country, in some countries you can't do machine learning because you don't have enough robust, the mature data ecosystem, and basically you don't need a data scientist, you need a data engineer first. But then we have data analyst and data scientist. So I think Andrew Barkov just let's say like to lit up the fire, because you would expect probably data scientists to be here, not data analysts, but it's really hard to distinguish, and I don't want to distinguish. Just I like to think that those names, they are coming, and they are how we perceive them, it's also changing. And actually, I will introduce also, sorry, not machine learning, but I will introduce machine learning engineer. So okay, now where is the difference? Yes, with data scientists. So actually, this process that you focus on making the machine learning more automated, ready for deployment, and basically a swift process. It's I think it's created another job. Yeah, that's why it's here. So machine learning engineer. So now that's a combination of, for sure, that's a person who knows machine learning, that's in the name, but also engineer. So that implies that you know how to handle data and you know how to handle tools to transform data into, let's say, insights and build models on that. And that's actually also implying that we have some tools that are dedicated to machine learning, and basically like I can call them frameworks. So if we think Python, then or C, then probably TensorFlow will come up. Probably scikit-learn is also good here, but yeah, we can make them also in like in Java. We have also some frameworks, but not really wide known yet. So today actually we will go through MLJ. That maybe it's a really good candidate for this framework in Julia. So just to set up what actually is MLJ. This is something that machine learning engineer would use in my idea, my opinion. And then, okay, so then data scientist was a little degraded. And I think data scientists would rely more on visualization, the data frames, plots, and telling the story, maybe some confidence intervals and more statistics. But yeah, the ML part was kind of taken by the ML engineers. So just to, this is this part, and then we have, yeah, as I said, this is not for today, so this will be really brief. We have a DevOps taking care of model deployment, serving, monitoring. Also, there's a maintenance. Actually, here I a little disagree. I think this should be DevOps and both of those roles here. But this is actually, those are people that are software engineers, yeah? So yeah, application developers. So okay, your model is putting out JSON, and you know that there's a dog and cat probability, but probably in the app you want to have a nice graphic, a nice front end, and someone who will be a developer and put it in this way. So so actually this is quite important, and also yeah, like DevOps here, yeah, it's kind of all about automating the problems you may face, because yeah, I mentioned scalability. So for sure, this is for let's say DevOps. So making more instances of your model to serve people if it's not sufficient. So also in case of machine learning models, we have this monitoring. I think, yeah, I don't want to go into details today, but the important part here is that your model may degrade. Yeah. And what basically I gave you a good example of degradation before. So you have a service that's tagging the people on the photos, and then you make filters, yes, and no one is tagged correctly. Even worse, maybe they are incorrectly tagged. So yeah, basically you need to start over, but you need to monitor to know this. So there's a lot after deploying, after training and evaluation, and I just want to set this picture that this is a big thing. And just to finish this diagram, I want to highlight those arrows, because they are sad arrows, let's say, because they go from model evaluation to previous steps. So basically, as I said, if your model is bad in performance, maybe do a feature engineering. If your model lacks data collection. If your model is not doing what it does because there are filters, then go to goal definition. Yes, and actually, yeah, like in December, I saw something like that, but in the, let's say, real world presentation by, let's say, a big e-commerce in Poland, actually, but there were even more arrows. Believe me, there were arrows like exit options everywhere. So people are thinking about it, that whatever the time you can just go back or terminate the project, but of course, yeah, then there is this problem of you invested in that, so you want something back. But yeah, there were arrows from model deployment and also from monitoring back here. So so this is actual practical diagram, to be honest, and it was shown more or less in this way. Yeah, so now let's go to, let's consider this a theory ended, and we will move to MLJ, but I already highlighted that MLJs, you can consider that this is a tool, but like a framework. Basically, from like this diagram, it will allow to like those four and maybe model deployment. Those it's covering those. Yes, so it helps you to go swiftly through this process. So in particular, to make your cleaning fast and efficient, to help you evaluate the model. And tune hyperparameters. So basically, yeah, we know more or less what we want to do in the machine learning process. So those frameworks, they are they are delivering the abstractions or the concepts, the say maybe even objects that you need in the process. And we will also highlight this what is imported, because actually something is imported into the environment. But I will also mention abstractions. So it's something you need to learn what it is in this particular framework, but when you learn it, it allows you to speed up the development process. So yeah, before we actually load the packages, we have we need to use data. We are doing machine learning, so we'll use the bank marketing data. If you click on the link, you will get to the source. And actually, I think we can move back to repository and go into this txt file. So yeah, I mentioned that, but CSV file is the data, obviously, and in the txt file we have a description. What I think this is, we can consider this goal definition problem. I don't want to focus much on the data because we can actually spend on that like 2 hours just to think if we are interpreting this correctly, and what we need to do with the columns. But let's get a glimpse of what we are having. So yeah, so it's a data from the UCI repository. It's quite popular repository of data sets. Yes, it's a data about actually it's not so straightforward here. I know what the data is about, but this is about bank clients who were it's about bank clients who were contacted to get and advertise with a term deposit, so they can take the deposit, take this new product or not, and that's our target variable. So actually, I will go to the end. So this is output variable Y, also common name. So it will be either yes or no that the client has subscribed to the term deposit or not. And also this is like a quite clear signal, because the question is, okay, what we can do with that? Yeah, because if we have picture, yeah, we can do a lot of pictures. Like I had this face recognition, but you can have object recognition. You can have like semantic partitioning and other stuff. Here we have yes and no values. So we'll do a binary classification. So we want to build a model who will tell us if a client has subscribed or not. There's like 20 attributes that are our predictors. So we have, usually in those situations, we have like bank client data, we have some macroeconomic situation, and also this is set up in the marketing campaign. So also I would expect that we have some variables related to marketing campaign, like how many calls were done. So from the bank client data, we have a age of a client, we have a job that is categorized into like a finite number of classes. I think also that's a good point to mention this unknown, because this is happening a lot here. So unknown is null. Yes, there's no information. And actually, yeah, at the end there's the sentence that there are several missing categories. They are all they all have the string unknown in them. So actually it can be a possible task for us to, like a cleaning job, yeah, to input the data. So basically to fill this unknown with something that we expect it to be there based on other features and data points. But actually, just to, yeah, as I said, actually just imputing the data is quite, let's say, cumbersome. So we can also make a different approach, and as said here, that this can be treated as a class, because if maybe there is a chance that this unknown is actually happening in the situations that someone don't want to give their, let's say, job, or maybe don't want to disclose information, and then this is actually a separate class. So this is not missing completely at random. And it will simplify our job. So we will, okay, then we have no missing values, but we have unknown classes, like unknown value. So we have marital status, education, default. So yeah, default was already mentioned about corporates today, but this is if someone is paying their credit or not, their loan. Yeah, so loan related data, and this is, yeah. So sounds like maybe something related to term deposits, but we will not do what Mateusz did. So we will not think about the relations per se. That basically we want to predict if someone takes term deposit or not. So it's a little simpler in machine learning. We just want to have a lowest error that is possible with the models we have. And we don't care about assumptions, and also the models are built a little differently. So yeah, actually in the econometric approach, I think we can basically do a linear regression machine learning way and econometrics way. But in econometrics, we can handle, let's say, low data cases. We have a lot of assumptions that were like mentioned by Bartosz like 4 times that they are causing problems, and yeah, and there was ordinary least squares estimation. So it's all yeah, all different in machine learning. So we need more. We need a lot of data compared to econometrics. We don't care about assumptions. We cared about errors in the end, or some metrics that we are calculating. And actually, least squares wouldn't be good for machine learning. And why? Maybe you know why least squares wouldn't be good. No, it's like for, let's say, machine learning approach. If you want to build a linear regression with least squares, is there a problem or not in this setup? So actually, the problem is the data size. So then this matrix calculations, they get problematic, kind of. If you get to millions, and then you have n times n, yeah, or yeah, you have matrix calculation. So actually, in machine learning, a lot is happening with iterative approach, the gradient descent, and basically this is approach to handle the big data that we are putting inside. And this is a linear regression is a good bridge between those two words, but a totally different approach for that. So also we have a set of attributes that are related to the current marketing campaign. So this is related to the actual last contact during the campaign. So just think that remember that someone is calling you to ask about this term deposit. So there is a contact communication type. We have a month, day of a week, and there is also a duration. And there is a quite important note that this attribute highly affects the output target. So in particular, if duration is 0, then output is no. And the creators basically say, if you want to make a real predictive model, don't include that. And actually, that's a good example that we will use, but we will discard this this variable with MLJ. Also, we have other attributes like number of contacts performed before the campaign. So yeah, actually, as I said, it's not really that crucial to understand every one of them, but we want to process them efficiently and use in the machine learning model. Also, we have 5 social and economic attributes. So this is something more general. like employment variation rate in the country, or like inflation, like consumer. Oh, sorry, this is actually a consumer confidence index. So it's slightly, there's consumer price index. So that's like an inflation indicator. I think that's sufficient to data to work on this task. So we will see how good we are, and we will not care about relations. So actually, I think the analysis will be a little straightforward than in the econometrics approach. So yeah, actually, let's start with doing something in the code. Yeah, but one note, this is related to base Julia. So you can see we are doing something with the logging package. So I will just start this. I will load those packages without the last line, without calling the last line. So logging is just a basic feature of every language, and Julia is no exception. So we just want to disable the info level messages, because MLJ has a tendency to be very informative. In short, so it's really good. But if I am presenting in front of the audience, it's just messing with my, let's say, output. So I just want to highlight that we can do something like use a macro that's called info, and this will basically use the logging capabilities, and it will log on the info level. Yeah. So I think even in data frames there is a lot of those in the code. So you are informed that you are maybe doing not something really expected, but it's not a problem, or that you done something and this will result in something else. Yeah. Then we also have a warn level. So you see it's a little more dangerous, like aggressive. Like we have the place where it occurred, and the warning is I think it's a little more warning actually says you are informed. So maybe let's say you are warned. Yes. And also we have an error level. I missed one level, but this is on purpose. So you are let's say you are errored, and now it's even the text is red. So this is quite nice in Julia and easy to use. Also the lowest level is debug. Yeah, so maybe let's make you are debugged, and there's nothing. Yeah, so default level is info, and if you put debug on, there will be a lot of output. But yeah, there's also an option to enable the debug. It's not really important for us. We just want to turn off debug and info level. So that's exactly what this line here will do. So let's run it. Yeah, and now we will see much less information, the pop-ups. Let's load the data. So yeah, I will of course use a data frame for CSV. It's a really good package, and it's supported in MLJ. So why not use it? Yeah. I think maybe I will zoom out a little just to see what we got, that everything is fine, as Bogumił said. So first rows, last rows, they look the same. So yeah, I think jobs are jobs, age is integer. Okay, it's quite important that in Y we have no and yes. Looks good. So actually it's the data we want to use. We have 41,000 observations, 21 columns. So yeah, so this I would say this is machine learning approach with this data. And now let's actually apply some MLJ to that, because right now we didn't use MLJ at all, but we have the data, we have the logging set up. Now there is the first like abstraction, or maybe a feature of MLJ. So actually MLJ introduced something that is called scientific types. Besides, here it says data types. In the MLJ documentation, it's referred to machine types. And when I talked with Bogumił, he said use technical types. So everyone has a different name, but basically data types are related to those here: string, float, and integer. And MLJ put something on top of that, and this is the scientific type. So there's a function called schema from MLJ, and if you call it on the on data frame, so it doesn't have to be a data frame, because anything supporting the table interface in Julia is supported. But yeah, let's work on data frames. You can see that we have the type, and this is exactly what was presented above, and we have the psi type. So maybe I think we have. We don't have everything from this list, but yeah, when we are doing machine learning, we are not explicitly like if you have integer, yeah. So 1, 2, 3, 4. So this is a continuous variable or ordered variable, or sorry. Okay, so I don't know really, to be honest, what is it, but you need to tell the program what is it, yeah. In the end, here, at least in this example, but like in R and Python, I think like most frameworks, they are implicit about like if you provide them the float, they will assume this is continuous. If you provide them integer, they will assume it's continuous, or maybe not. But you need to know. You need to know what you imported, what function you are using. And actually, every package like scikit-learn and the like other like XGBoost, they work on their own, let's say. And here we need to specify explicitly the scientific types. And this is not how data is stored in the memory, but how it's interpreted. So we know that yeah, what is our target variable in the like it's a binary like nominal variable, yeah. So here it will be a multi-class, but yeah, it's stored as a string. But maybe if this is a string, then it's a textual data. Yeah. So we want to do a natural language processing. Yeah. So actually here MLJ give us more work to do. So bad for us, but in the end it will pay off, because it will automatically know what to do later. And actually it's also good for at least I get caught in the way that I actually I had to sit down and thought what the types should be there, and I basically like misassumed the type. I assumed wrongly, and then by thinking what I should assign from those scientific types, my like understanding of the problem was better. So I think it's quite good decision to put this burden on the user. So yeah, we have continuous like age or length of something, or price of the house in Boston housing data set. It's yeah, it's, you know, we are in Boston also, so it's popular data set.
Yes, so my thinking about this is the following. So of course you like to get something by default. So you know, by default, yeah, MLJ will assume something, but it's better to be at least forced to look at it, just to ask yourself a question: should I think about those scientific types? Maybe in some cases you don't, and that's just one line of code, so it doesn't harm you that much. But if the data is such that you should have thought about it, it's much safer to be really prompted to do this.
Yes.
And if you, for example, consider many machine learning frameworks that are those so-called AutoML frameworks, this automatic machine learning that are available in the cloud, actually they also ask you to specify, they propose something and they ask you to specify this scientific type. So this is not a unique feature of MLJ, but actually the other frameworks also have this concept, because it turned out to be really important to make sure that we properly analyze the data.
Yes, so yeah, this is for sure not explicit, like not specific to MLJ, but yeah, this is important. Like yeah, in those AutoML services that are like they should be really let's say easy to use in the cloud, and they basically say like in advertisement, like or in the documentation that those are this so automated ML, yeah, machine learning, automated machine learning. So the documentation says that even people without the machine learning knowledge can do the job, but do the work. But yeah, you still yeah, you still need some knowledge, but maybe you don't need to know the intrinsic details. But yeah, those scientific types, let's say how they are called here, it's really important because some models just don't support count data, yeah, or maybe the count data is interpreted differently. And actually, there are some defaults, and you may tell me if they are good. Yeah, so actually we will multi-class. I already said our target variable is multi-class. This n is explicit number of levels. So we will have 2. This will be multi-class 2, and ordered factor is for ordered variables, and they also have some levels. And actually, I lied a little because our target variable will not be multi-class, but I will say in the second why. So we have count data. So count data is like how many chairs are here, or like we have count data like how many calls were made to someone. So you can't make a like 2.5 call to someone. Yeah, so it makes sense. Those are just discrete numeric variables. So the schema function is showing us that right now the default assignment. So we can actually see if this is what we expect. Okay, so a lot of textual, count data, and continuous. So maybe floats are good. Like the default is float is continuous, string is textual, as you see. So I don't even need to say what are the defaults. We can see them. I don't like it because everything from string was turned to textual. Those are not textual variables because job has a set of jobs inside. So all of those should be nominal or multi-class. And so actually we don't like the default. So how to change it? Yeah. So there is a really important coerce function that will change the scientific type. So we want to make h a continuous scientific type. I hope you agree, or you may disagree if we let's say if we make it even if the h is just an integer, not with a decimal point. I think we are living long enough to consider this a continuous. Yeah. And we want to turn or textual to multi-class. So we can see we actually do the same thing, like turn something to a different scientific types, but here we change a column, and here we change the other scientific types. Yeah, and it's all in the one function invocation. And also I am changing y to ordered factor. So let us see the difference here in schema. And I will say y ordered factor, not multi-class. So yeah, you can see the coercion actually extracted this distinct number of levels. So if you forget how many different levels are there, you can also take a look on that. So I think 12 jobs, I think it was mentioned here somewhere, or maybe not. Yeah, but basically this should match with what we have here. But we have 12 classes, and now I think I like it. Just one also important effect of this coercion. Okay, we change the scientific types, but we change the data types as well. So the MLJ can't make this like, okay, so you will keep a string here, but I will call it a multi-class, not textual. So actually you need to change the data type, but it's also for your and my own good, because actually categorical value is not a base Julia type. It's a specific type designed for holding categorical values. So actually it holds the information about the levels, so all those 12, and also the actual data is stored in as integers that are pointing to correct levels, so it's more performant. Yeah, so Julia is all about performance and composition, but yeah, here categorical value basically help you with that. So we changed the data types, but it happened automatically. And okay, I owe you the explanation why why y is an ordered factor, yeah? Why not multi-class? Okay, so actually for that, you need to go to MLJ documentation, page 6, section 8. Yeah, so just joking, but basically MLJ, if you have a classification and you use multi-class, then MLJ don't know which class is the positive one. Yeah. So here we have binary classification. So when we have this binary classification, yes or no, we want to highlight, at least I like to call it that one class is more important than the other. We want to focus on detecting this class, and then we call it a positive class. So I guess here you know what is positive, what I would treat a positive. So if someone has a term deposit, so agree to do that. If you are if you have the data about illness, some illness, then probably you have indication if someone is ill or not. So then I will treat the ill people or ill patients as positive. So we can check what levels our y has. So actually we have no and yes. And okay, so which one is positive? The last one. The last one, so here, yes. So it's good, yeah, because we want yes to our positives. If we want to change it, we can make it so like this. So just, yeah, like bang at the end of levels, it will change it will mutate the levels. So let's call it, actually, the output is not indicative that this happened, but if we do that, it's the opposite. Yeah, so it's the opposite, but now I need to fix it. I want really yes to be our positive. So yes is positive. That's the only thing why this is ordered factor. Still can be a multi-class. It will not fail later, but then we will have a big warning. MLJ will say, I don't know what you want to do, so I will do something I just want to do. So I will just assume this class will be a positive one. But yeah, now we have actually we've done a lot because we have assigned scientific types, and now the rest will actually all be like all the processing right now will be based on the on those scientific types. So a really good idea to have them, and we will see how it happens. So yeah, before we actually train and validate the data, I want to do a minimal example of data preprocessing. Why minimal? So again, like if I can quote a study that says that like estimated 70% of data scientists or ML engineer job is cleaning the data. So I don't think we want to spend that time on processing, but for sure this is important and a cumbersome job to do. So to clean and process data. Just reminder that actually owners of the data recommended to get rid of the duration. So if we make a minimum, median, and mean of this grouped by the y, we can actually see this is true what was said in the documentation, that for no we have a minimum of no, but for yes it is never a minimum, because if you called someone, then duration must be higher than 0, yeah, because there was a call. So as we know that this is highly affecting the data, we want to get rid of this. And how to get rid of that? So in Python, we would use drop probably on the pandas data frame, but what MLJ gives us. So yeah, we want to prepare our data for further modeling, and it means that right now, by preparing, I mean we want to split it horizontally. So we want to just take some columns and make them the new data frame. And this is so yeah. If you are familiar with scikit-learn, this is kind of the same approach. So we are splitting independent and dependent variable into separate data frames, and for that we can use unpack. So unpack is just cutting it like this, and actually it can take few arguments. So first argument is a data frame. The second argument says for the first things that you give me as a result, just give me the column y, and this is our dependent variable. And for the second argument says, give me everything except duration. So this is not not equal operator. So give me everything except duration, but I already gave you y, so I don't need to explicitly mention y. So it's cutting this data frame and giving me this in the order I give. So actually I could put even more here, but I don't see a reason why I need to produce a third one. Yeah, so actually, yeah, I wanted to take a look, but it's already here, what we produce. So y is a categorical array. As I said, this is a special construct for let's say machine learning and other data applications. So we have looks good. Yes, we have no, we have yes. This is our independent dependent variable. And in X we have a data frame, but we had 21 columns. So y is gone, duration is gone. We have 19. So we are more like set up in the scikit-learn approach that we have dependent, independent data set. And then we have actually we'll do two things at once. So one thing is that we will do this. We'll do two pre-processing steps, and I'm quite happy that Bogumi showed them both on the first day. So one will be standardizing of the numeric features. So actually, it wasn't called standardizing, but we had a z-score on day one, and actually I think we had z-score today mentioned. So actually, we'll subtract the mean from every column and divide by the standard deviation. So our magnitude of values of our numeric features, I will not tell MLJ which are numeric because it knows already, will be more or less like on the same magnitude level. And also we will do one-hot encoding. So every class from the categorical will be a new column in the data set. The MLJ also have it allows to transform skewed features. It has a imputer. It's called imputer to fill in the missing values. So there are some standard. They are called transformers. So this is not like a robot, yeah, but an object that is doing something with your data. But this is not a machine learning model that is capable of predicting. So. So that's the first thing that we will do, and at the same time, we will also introduce the one abstraction in MLJ and two functions that are connected with that. So the machine function is like in short, it's binding something, like it's binding model or pipeline or transformer to the data. So it's basically creating an object that holds both, and then we can do something with this object. So we can fit and transform in particular, and this is also a lot like scikit-learn. Yes, so the fit like transform is exactly the same as in scikit-learn. The fit is different because it has a bank. It has a bank because it's changing the machine. It's mutating the machine structure. And also to make it even harder, we will introduce the pipeline sign. So I think Bogumił has shown that the chain macro that was chaining the operations. But also there is a let's make a really simple example that we can pipe operations with this base Julia. This is base. Yeah. So you have it always a base Julia operator. That what we want to do with that. Well, let's make a sum of this vector. So yeah, so it's basically allowing us to put those operations in a like visually better way. Or I think in R, like our users will be, I think, quite happy to see that because it's used a lot in the R ecosystem. So I can maybe put a log here just to see that I can do two operations, not one. So we'll utilize this for MLJ because it's basically enabling composition, really nice. And actually in machine learning, context, this composition basically means that we can make a pipeline. Yeah, so we can automate or some steps that they are always done one after the other. And what we want to do here, yes, actually, maybe just let me call it all at once. So we are calling a standardizer. So those two, standardizer and one-hot encoder, they are from MLJ models. It's always loaded into the environment. Basically, MLJ creators assume if you will load the data, probably first you want to preprocess it. So like documentation in MLJ is actually kind of standardized and it's quite extensive always. So I don't want to go through this. I just want to highlight that basically we know what we are doing. So kind of a z-score and one-hot encoding. We'll see what like actually we learned those structures. So they have some parameters that we learned. So actually we want to make a pipeline that first we standardize and then we one-hot encode. And of course, standardizing is for continuous variables. And I think, and it says that this standardize only continuous. So this is the first thing we gain from scientific types. We don't need to specify the which are continuous. And one-hot encoder encodes only multi-class parameters, variables. Okay, so we have a pipeline. So actually, it's not even a transformer because this is a transformer and this is a transformer. And we compose it into the pipeline. Then we bind a pipeline to X, and X is our independent data frame. So independent variables data frame. So this reprods wrapped is just some abstraction that MLJ provide us, and we can see this is right now it's trained machine. So actually, maybe let's divide this cell into multiple ones. So if I call it again, it will be an untrained machine, and it will give me the definition of the pipeline and what it has inside. So if I fit it with the fit function, it will be trained. So it learned something from the data that was bind to it, and it mutated the parameters. And then if we want to actually get the standardized and one-hot encoded features, we need to call transform. So again, scikit-learn kind of pattern. And maybe let's just look what happened. So 62 columns, number of rows looks similar, but 62, we had 19, now we have 62. So actually that's a good sign. So all the jobs were one-hot, like multi-class was encoded, one-hot encoded. So we can see that this is a mark for an admin. If someone is an admin, this is a blue-collar job, and so on and so forth. And this pattern happened for all multi-class. If we want to check if standardizing happened, then age was a continuous variable, and now it doesn't look much like the age because it's negative. So it looks like the standardization worked correctly. And I just want to take a look at the end what happened. Yeah, so we also have a standardized variable here. Actually, integers are still as they were, so it didn't affect the count data. Yes, so we made this decision that some of those are count, and it just didn't affect those. I really like this composition. Then that yeah, you need to make one effort to standardize the data, like to put scientific types, and then you have like you are basically sure that the functions are doing what they expect to do. Maybe one more thing, if someone was wondering why MLJ was here, like I have MLJ dot and not here, because I'm calling a function from MLJ in both situations. So yeah, okay, so now it's calling me a different error here. Yeah, so if there are two actually the message was that the transform is both in MLJ and in data frames, because it transforms the data frame. So I think using MLJ, we need to be quite wary that we are importing a lot of functions, a lot of functions, because we need them to use, yes, in the process. And so actually transform, probably, I think transform will be the first one that we will have a clash, because if you are using MLJ, probably you have data frames, so both are exporting transform. But yeah, Julia was kind enough to show that both, like, which packages export it, and we can just make it right by fully qualifying the name. So this is like a domain name, yeah, fully qualified. There's no ambiguity here, so it's working. Yeah, just to finish the pre-processing part. So actually, what happened when we do the fit? Because when we did the transform part, hello, yes. So when we did the transform part, we actually commenced the transformation of the data. So this job column was transformed into multiple columns. But when we feed the machine, we just calculated some parameters. So this is not a machine learning model, a standardizer, but it has some tunable parameters in the sense. So if we call standard function from the MLJ fitted params on the machine, so this is, it doesn't matter actually what is it inside, if this is transformer or a machine learning model. I mean, it has to be a machine. Yeah? So actually we have one hot encoder, which is quite big. And not interesting, to be honest. So it just keeps track of the levels it has. Yes. So so I want to get, I always mess with this name. So I want to get the standardizer part. And what we have here, so we can see the variable names. So we can actually check which features were standardized. And we have, yeah, basically this core needs two parameters, if we can call them. So we need a mean of the column, and we need a standard deviation, and that's exactly what was fitted in the fit step. So we learned that, and now this pipeline can be used on the unseen data, and it will use this mean and this standard deviation. So even if the data changes, yeah, the new data that comes, it will use those. But that's what we want to do, maybe. So we'll just keep this state in the pipeline. Okay, so now we move to some section called that MLJ is a repository of models. Actually, that's quite, I think, also quite interesting part of MLJ, because, okay, maybe in comparison, scikit-learn and TensorFlow. Yeah, so basically in scikit-learn and TensorFlow, you have functions that are like the source code is in those packages. So in scikit-learn you have all those regressions, like random forest, but it's all in the scikit-learn. And the same for TensorFlow. Yeah, I guess we can argue that maybe we can implement our own. That's true. So you can make our own models, but basically it will be still based on the, let's say, scikit-learn. But MLJ is not trying to reinvent the wheel, in the sense that there are not a lot of machine learning models implemented in the MLJ framework itself. And what it does then to get the machine learning models, so we are using the packages from the ecosystem that are compatible with the MLJ. So if someone, I don't know, Mateusz, maybe you will implement some new method in Julia, some machine learning model, and then you want like people to use it with MLJ, then you can just align with the interface of MLJ, and everyone can use it in the same steps I use it here. So I think that's quite a good incentive for any developer, that you don't have to like think about all those evaluations, method, and the training, because if you fit to few functions that you need, then everyone can use it here. So I think there will be more and more coming, but basically it means MLJ is a repository of models. So it keeps tracks of the packages that can be used in this context, in this framework. And so actually, okay, so how many models are there? So yeah, there is this fancy, I think it's quite fancy function called models. So, okay, take a guess. How many models will be returned? This will be a vector, and then the number, like the collection size. How many models are in MLJ? Okay, you are close if you cut the last 0 and change 3 to 2 at this point. So let's call it predicting the future. Yeah, when your models get in. Yeah. So you see there is a 200 element vector. Yeah, I think documentation says 180, so it's not keeping up. But yeah, it's not. Yeah, it's much or not. I don't know. Like it can grow, it can grow, but like you don't need your developers. I mean MLJ developers to make it grow. You can, someone else will put it here. So so actually this is just like a documentation about each model. So if let's take a first one. So we have an outlier detection neighbor that is actually, this is unsupervised model. There's a dog string. There are some other interesting like points here, or we know what are the hyperparameters. So there's a lot. I think it's worth to let's say like basically every developer needs to fill it. Yeah, but the more information you have, the more automated you can get in the end. So even if you have like a license of the package, actually it's quite important in the end if you want to use it commercially. So you can also use some models that someone will pay you for using them. But yeah, so this is, we can search for models really easily, and this function alone is quite like a search box. Yeah. So if we put a string here, like linear, maybe let's call logistic here. Okay, first that came to my mind. It's second to came to my mind. Yeah. So yeah, I put logistic. So actually, what the function did is it searched the doc strings, so the documentation, and get me what has a logistic in it. So so you can see logistic classifier from MLJ linear models. Okay, so I lied a little, but not let's say not really, because yeah, MLJ linear models is just a package that MLJ developers are maintaining, but this is a separate package from MLJ itself. But yeah, we have it here, but also that's quite interesting. Yeah, so we have scikit-learn, and I broke with zooming. Okay, I wanted to make it a little. So we have scikit-learn here and here. So it looks like it's a Python package. Yeah, it's a Python model, and it is actually, because Julia is there's a scikit-learn JL package that is just wrapping the scikit-learn function. So actually those models are also from scikit-learn. So then maybe those 200 is not that bad. Yes. So we have some scikit-learn. There is this this property of each model is pure Julia. So it can be, yeah, if it's false, then it means it's not from Julia alone. If it's true, then it was implemented in Julia. So can we get the, okay, let's check how many from like Python or like not Julia packages are here. So yeah, I zoom out and broke again, but yeah, we can actually pass a function to this you can pass a function to this function, which should evaluate to true or false, and then it will filter the output. So let's put is pure Julia here. Actually, I'm doing the opposite of what I told you, but I wanted to do this anyway. So we have 101 Julia, pure Julia models. So almost 50-50, yeah, 100 like 99 non-Julia models. So how can we get the opposite? So we need to negate, and this is the tilde operator. So yeah, here it's because the bank is let's say used elsewhere. but here if we use the tilde, we get, basically we get a lot of scikit-learn. We have outlier detection Python. Another package, we have XGBoost from Python. So actually that's quite interesting. I think this XGBoost is like there's XGBoost implementation in Julia, but also wrapper around Python XGBoost implementation. So it's getting complex quite fast. But yeah, it's quite searchable. So maybe let's make some assumption that actually we don't really care if something is pure Julia or not. Yeah, so we have some data, and probably we want to search models that can work on this data, right? And what it means, it can work on the data. It means that all the data types in the data are somehow handled by the model. So there is this nice, again, function from the MLJ matching that is returning all the models that are compatible. So actually, it gets pretty sad because we had only 4 models, but actually I didn't call it in the right way because X is it's my data frame before I one-hot encoded and standardized. Yeah, so I had a lot of multi-class there. So actually, I need to call on X prepared. Yeah, so prepared was done here. So now let's see if this helps us a little. Okay, 13, not bad, not, or maybe not good, not terrible, but yeah. I think also I want those to be pure Julia. So how can I do both, like having this matching and that all those are pure Julia? So maybe let's make it a little more readable. So I want to make a condition, and this will be an anonymous function because I can do this in Julia. So I will call M that will be used in matching, but I need to now invoke M here and X prepared and Y. So this first will match my data types. So also see that there's Y here. So basically what we get should we should get classifiers. Linear perceptron, it can also work for regression, but random forest, decision tree, okay, those are classifiers indeed. But also I want my M to be is pure Julia, so I want to get only Julia implementation. And let's see how it works. Okay, so now actually we just lost one. So we just lost one model from, I think, scikit-learn. Okay, so what we do now? Do we take all 12? So maybe for the purpose of the presentation, it's not it's too much. So actually, I decided on 3 of them. It will be a random forest classifier and Evo tree classifier and linear perceptron. So so actually, I can't use them out of the box because they are not loaded. So what we actually browsed here, this is just a metadata. Yeah, we don't have those packages. I mean, you have because you just use the project Tom that has the packages. But before the models are loaded, they like those packages listed here, MLJ decision tree interface, Evo trees, and beta ML, they need to be in your environment. So I think it's a good decision. Like imagine if you let's say you want to have those models all in, yeah. So then you need to load those, like, I don't know, 50 packages, and like, okay, first thing, a lot of dependencies, and second thing, a lot of clash. Why a lot of clash? So okay, let's see this, for example. How many random forest classifiers we have? So actually we have 3, yeah. So we have one from scikit-learn. I think it's well known, at least I use it a lot. So we have one from decision tree, this is Julia package, and one from beta ML, this is also Julia package. So and they will all load the same name. Yes, so we need to be a little careful with loading. And also sometimes you can see this package here. So MLJ is aware that the names, doesn't force developers. And anyway, how you can force a developer to change the name because someone else use it, yeah. So basically, it's handled by adding the package where it's needed. So now basically this load macro is importing the functions, the right functions from the packages that that I previously installed. So you installed them by calling instantiate on project Tom, but that's how we get free machine learning models we can work with. So yeah, we have two big let's say things to go. So we will train and evaluate the model, and then we will also tune the hyperparameters and evaluate the model as well. So that's like bread and butter of machine learning workflows. So how MLJ is helping with evaluating the data or machine learning models. Yeah, so actually with this snippet of code, we just we are evaluating all three models against three metrics, and also we are doing this properly. So we are splitting the data into training and test sets. So the model is not assessed on the data it is trained. So this is, let's say, a fundamental concept in machine learning, that if model may overfit to the data that it's trained on. So basically it pretends to be really good, but it's only good on the training data. But if you run it against some other data set, it's then performing poorly. So to do that, is actually we need to split the data set, but not horizontally like column wise, but we need to split it row wise. And actually there is a partition function in MLJ. Okay, so maybe I should call it with, if I call it with a question mark, I will get of course the nice and extensive description. But basically this is the function, like another brother of the unpack. Unpack is for column wise. This is row wise, and this can help us to split the data into chunks that we can use later. But it's quite interesting that in this piece of code we are not using it anywhere. So actually we are using another abstraction from the MLJ. So I think the core part here is evaluate. So actually we don't need to split it the data before. It's taking more time than you think to split the data every time. So actually we can just call evaluate, give it a model, give it the training data, give it actually not training, give it a data, give it this independent and dependent variable. Just tell it how to split the data and what measures should be calculated, and it will do the job for us. So maybe just let's run it first. I think it's compiling for the first time. So yeah, it's kicked in the end. So actually it will print some evaluation report details for us for each of the three models. Actually, I don't know which measure is the best for us in this case. Maybe if with the business case or with more details about the process, we can pick something good. But usually in the, I think like also bread and butter of the metrics in the binary classifications area under the curve. And also F1 score is pretty common to see. But yeah, I don't want to get into details of those metrics because this would take us the remaining 30 minutes. But you can see that basically quite, I think, effortlessly we get a report for all the three models. So actually, yeah, accuracy is quite high. At least for those first two. Like, yeah, maybe linear perceptron it's not doing well because we use the default hyperparameter. So basically we just use what developers said it's nice like nice to use with respect to parameters of those functions. But okay, then let's discard linear perceptron. And yeah, it has a nice progress meter, but decision tree and that this is the decision tree, and random forest is doing much better. So accuracy is comparable, but actually F-score is quite small. So it indicates that we have some imbalance in the data. Probably we have many less term deposits. So actually we can check. So if we make a group on our data frame by Y, and if we and rows, I think this will be, I think I missed a symbol somewhere. Or maybe here. And here it will be. Okay. Okay, my last combination work. Yeah, I always have those problems with S and not S. So yeah, actually it looks like 10% more or less, give or take, of the Y is yes. So we are more interested in yes, because people just took our term deposit, and this is an imbalanced data. So actually accuracy is quite high, but it's not a good metric to look at. So maybe if we look on the F-score and area under the curve, they are lower. But in both cases, the random forest is better than the FO3 classifier. So we just make a really fast and let's say brief evaluation of three models. We use the default hyperparameters. So maybe if we change them, the linear perceptron would be better, maybe the best. But just to simplify, we'll use the random forest classifier for the hyperparameter tuning. But before we go, let's maybe stick here a little. What actually happened here? Yeah. So actually, as I said, so MLJ is just making the common things easier. But in the end, what we did here is the following. So first thing is that we split the data. Yeah, split the data into the training and test data set. Maybe we can call it validation. Maybe we can call it test. When we have only two, then it's quite simple. So yeah, in general, three subsets are often enough for our work. But here we will use here we'll use two. We just have we are not tuning the hyperparameters, so we are using this holdout. This holdout is basically telling us 80% of the data should be a training data, and I am just using RNG, so random seed of 42. By the way, do you know why 42 is used? I can see you know. Yeah. Yes, this is. So what is it? This is answer to the meaning of life. Yeah. So really good seed and let's say a data science like Easter egg. So yeah, this is from the Hitchhiker Guide to Galaxy, if I'm not mistaken. Yeah. Anyway, yeah, you can Google it, but it will be used a lot here. So yeah, we want to split. So I want to use partition to split into the training and validation data set. Actually, I need to split both my independent and dependent variables. So I need to put, I can use one data frame, but here I will use the tuple of the data frames because I split it before. And I need 0.8 of a training data, and I need, I think I also need to use RNG of 24, 42, and I need to set a multi-parameter to true. Why multi to true? Because I have tuple. So I want to synchronize splitting of those into the same data sets. Okay, so I got something. Maybe I will need to catch it into some variables like x train and x test, and then the second tuple that will be y train, and let's call it y test. And let's put a semicolon so it will not print the output. Okay, so now we can, I think, take a look or take a peek. So yeah, we have we have training data set, independent variables. So is it the correct number of rows? So if we multiply 0.8 by n rows of a data frame, then it will be rounded to this number. So then X test should be, yeah, so 20%. Okay, so it fits. I think we will not really check it for the, just take a look for y train. So we have a dependent variable for the training of our model. So yeah, first step is done. So what comes second? The second step would be to actually to train the model. So let's take only one, not three. So the forest, random forest. If I call it like that, then you can see the default parameters of our model. So number of trees is suspiciously low, but we can help with that in the hyperparameter tuning part. But yeah, we need to train this model. So I think you should already know that first we need to wrap it into the machine and bind it to the data. So yeah, I bind it. I have okay, and I bind it incorrect. So I need to bind a train one. Yeah, train that I split it, and I want to bind y train. So this is a supervised model. So I need both data sets here. Actually, I can also call a machine like that, but it will indicate that the model here is unsupervised, like clustering or like, yeah, k-means or dimensionality reduction algorithm like PCA. So yeah, so we want I want this back, this y train, and let's save it to mash, so like machine. So this is untrained. Yeah, we need to train it. We need to fit the machine. And now it's trained. Okay, so we have a trained random forest, and now the third step would be to maybe let's first predict on make a prediction on the test data. So how we predict in MLJ? Yeah, so I think it's quite straightforward that we will use predict on machine, and we will pass what we need to pass. We need to pass X test as a second argument. Yeah, so actually we get a prediction. Maybe let's save it to something nice looking like y hat. So just to remind you, if you want to put some Unicode characters, I just typed \hat and tabulator to have this nice convention from the econometrics, actually. Yeah. So actually we get a prediction, but maybe it's not what we are looking for, and this is the same case as in Python. So in Python we have two functions. Actually, I think they are methods in Python, as yeah, also methods and functions were raised yesterday. So predict by default is giving us what MLJ is calling probabilistic prediction. So we get we got a score for every class, and we don't necessarily get the prediction. So we don't get that the first observation should be no or yes. So if we want to get the deterministic prediction, that how MLJ calls it, we should use predict mode. And mode is the highest value. So we get what yeah, the prediction for our observations. I think in Python, in scikit-learn, this is the opposite. So predict gives us the those deterministic predictions, just yes or no, and predict proba is the opposite. So we get the score. But here we what we want to do. Oh, okay. So actually let's stick with predict mode, and the fourth step would be to evaluate or assess the model. So what it means, we need to pick a metric or measure and check the value. Yes, so either this will be an error that we want to minimize, or accuracy area under the curve to maximize. So yeah, in classification setup, we can think about the misclassification rate, that is opposite of accuracy. So anyway, we actually have those metrics, but yeah, maybe you wondered how they get here in the first place. So actually we were not defining accuracy as a function, yeah? So actually it's also coming from MLJ. So MLJ is loading a lot of metrics for us, and we don't need to define them by ourselves. So actually accuracy is a instant of type accuracy, so it's defined by a struct, but if we call it like that, then we get the documentation, and this is preloaded in our environment. So if you want to assign something to a variable called accuracy, please don't, because you will overwrite it. But you can, of course, fully qualify it with MLJ before the this object, before the accuracy. Anyway, yeah, we can. Let's try to use it even without. Okay, we know how to use it because it says here. So actually, we even called our variable the same way. So y hat, and y should be a test, y test to get the number. Okay, so if we look here and here, this is the same number, but it took us like 10 minutes to get there and here it took us 30 seconds even with precompilation. So let's try the F1 score, if it works. Okay, still matching. And then it leaves us with area under the curve. And we failed. So yeah, this is like intentional. So for area under the curve, we need not a mode, we need the predict that is probabilistic. So if I recalculate this y to this again, then I will get the area under the curve. Actually, it's a little higher than this one, so it may differ because of the because of the randomness of the random forest. Okay, so yeah, so we get a lot of metrics. So probably there's also a repository of metrics, yes. And yeah, I can ask the question as Bogomil did, what function we can use to get metrics? And actually, yeah, it's not metrics. So sometimes it's maybe you need to try another thing. So it's measures, but actually I make something not really sensible, so to say. I used measures as a variable. So remember, it was, let's say, a good name in the situation, but I forget this is imported by MLJ. You can then fully qualify it. And actually, we have 63 measures. I think everyone will find something for them. And again, this measure is kind of like a models repository function. So Mateusz, give me a measure that other than F1 and accuracy, or
area under the curve.
And also different than AUC because we have it here. Something different than those three.
Recall.
Okay. Okay, so actually we have two. So multi-class true positive rate, so different name for recall, and true positive rate that is also, yeah, we have recall, hit rate, sensitivity, true positive rate. So all those names are recall. So yeah, actually we get it by just searching. If we take first element, then we have more information about what it is, and yeah, this is maybe a little convoluted because this is a metadata, but we can do something like this. Also, another function imported by the okay, so I think I actually need to do this. So I need to find the name. Okay, so this is maybe recall will work here. Okay, so it's working for models in this case, or maybe if I put TPR to positive rate again. Yeah, so here actually info is okay. So if I again the last combination, so if I get the same thing for TPR from the repository, but info and doc is something that you can get to get more information about the models. Also, you can get more about the okay, let me copy this true positive rate as a class. Okay, so true positive rate, yeah, actually if we got the doc string like that, and then it's like a usual class, then we get more information. And also, yeah, info is working nice for the random forest classifier, will give us more. I think sorry, this is should be a little. Okay, it's almost working, but my model is ambiguous, so I should put it like, let's take scikit-learn, even if we don't use it. Okay, so yeah, now it's using here a comma, so we can get the metadata. If we use the doc instead of the info, we get the doc string. But yeah, for measures, you need to use the like not exclamation but question mark, and there's some more information. Also, there's great documentation online to check how those measures are defined. But actually, yeah, we have those 63 measures we can use, or we can implement our own and bind them with the MLJ. So yeah, we took much more time to actually do the same step that this evaluate is doing here. And this is really, let's say, expedited evaluation. Also, yeah, I'm here calling on the instance of the random forest to actually see what exactly model we picked, because we just do this really fast. And we have few hyperparameters here. So yeah, it's not, let's say in the real world example, we would actually tune the hyperparameters of all the models. But here we, let's pick one because it's actually taking some time to tune the models. And just because, for the sake of that, I want to, okay, so I think I need the forest to be assigned here. I didn't run it. So for the sake of time, let me run this cell, and we will work on the contents, because now we are evaluating again, but we are evaluating in the hyperparameter tuning context. And you can see that actually we are building 36 models. It calls meta models, but this is 36 random forest models, and yeah, it will take some time here. And I think it will be we'll get close until the end of our session. So hyperparameter tuning is usually done with combination with cross-validation, and yeah, when we are talking about hyperparameter tuning, it means that we have a model at hand that has usually in implementation, those are just arguments for the function, so we can actually pass a max def or entries to the random forest function, and it will we can change those hyperparameters. So those are the values that are affecting the parameters that are than calculated during training. So in the end, we can produce a better model if we find the right values for those hyperparameters. Unfortunately, usually we just need to take the data at hand and try different values. And actually, this is called hyperparameter tuning. So there are few standard techniques to proceed with that task. Here we are using something called grid search. So I arbitrarily picked two hyperparameters. This is number of trees in the model and maximum depth of the tree. So we will not get into details what they exactly mean, because we are this is not really that relevant for this exercise and we are short on time. So I defined that for number of trees in this model, I'm starting with 10. This is also the default parameter that we checked before. So number of trees is 10, and I want to go as far as 80 trees. And as when it comes to max depth of the tree, we start with the 2. So this is how deep a tree can grow, and we want to stop with 30. So we define the boundaries, upper and lower bound, for the hyperparameters. But then the question is how many values will be drawn between those two. Actually, this is quite simple in MLJ, so we just specify the resolution of 6 if we want to treat them, let's say, equally. So there will be 6 values of trees between 10 and 8 equally spaced, and max depth also equally spaced. So if you multiply 6 by 6, you will get 36. That is exactly number of models we are training. And for every model, we are also doing the technique that is called cross-validation. So there is, okay, so we have a random forest that is random, as the name says. So we have some randomness connected to how the model is built and also how the data is split into training and test the data. So cross-validation helps us with reducing the variability. So basically we are doing training and evaluation n times. So usually this parameter is actually k-fold, and you may encounter k-fold cross-validation. And then in, let's say, 4-fold cross-validation, you are doing, or maybe I would use 5. You can see here 5 splits. In 5-fold cross-validation, you are training the same model 5 times and evaluating this 5 times. But the only difference is that the training and test data is different. That is used underneath, as with this diagram. So blue part is at like 1/5 in the split 1 is the test data. The rest for the other 4 parts are constituting the training data. So if you want to check more, go to the link here. So actually this is from scikit-learn documentation. It's quite a nice diagram. Yeah, but actually it means that this 36 needs to be multiplied by 4, because for every model we have 4 iterations of training and evaluating. And we want to find the best hyperparameter values with respect to some metric. Let's make it area under the curve. Maybe F1 would be good, but let's go with area under the curve. Okay, so we trained this wrapper. This is another abstraction of tuned model. So it's doing a lot of things for us, but it's all wrapped with this tuned model and then in machine. So we are binding the tuning specification with the data. So after the training is completed, I explicitly set verbosity to 1 so we can see the progress. You can see some plots of the metrics. So it's reporting area under the curve for both entries and max depth. So this is like a, let's say, one-dimensional scatter plot. And there are 6 dots on every max depth and entries because we have 6 other values of entries and max depth. But if you want to see it 2-dimensional, like a heat map, it's here. So just to go quickly, as we are all at the time. So if you look on the 1-dimensional plots, it looks like number of trees, like area under the curve is rising, but then it's saturating around the 60 trees. Like it looks like 80 is still better, but we are not getting significant gains here. And when it comes to max depth, you can see we are first increasing the area under the curve, but then at 30, this started to drop. So actually, yeah, it's still, I will refer to fundamental concepts, but here on the left, before the maximum of area under the curve, we have an underfitted model. The trees are too shallow to get the best values of the area under the curve, but on the right, we are overfitting. So the trees are allowed to grow too far, and our estimates are getting worse. And this is all just reading the plots. And yeah, this is another, we have a machine that is fitted with the tuning, and we can call fitted params, which was used before, and extract the best model with the best model field. So this will give us the best random forest classifier. You can see that the max depth is indeed around 25. It's actually 24, like here. A number of trees is okay. So actually, I'm quite surprised. So yeah, actually the best tree is here. So we have, this is this dot in the two-dimensional plot. And we can just bring the best model into the evaluate to actually see the all the measures that we declared before. So yeah, accuracy is 90, area under the curve 795. So if we compare it to what we had before, just want to get back to 0.653, we get a little better. So this tuning, like get some performance out of the model. So we can, let's call it a tuned model. Of course, we probably should use more hyperparameters dimensions, but then it's get even more computationally intensive. And now we can use it to just predict. So we are using the already learned predict function, and actually here we are using a machine. So that's quite a difference, that here we are using a best model extracted from this machine. But if we can just go straight from, so we are tuning the machine that constitutes the specification of the tuning, and then we don't need to even extract the best model. This machine here, it's using best model by default. And you can see this is exactly the same output we got before. If I do predict mode, it's just a no, yes or no. So yeah, so this was a really fast hyperparameter tuning example. So basically, we wrap up the training process and picking the model. So let's also again call it a day, and our random forest model will be deployed to production. So it will be exposed to some end users. So also MLJ have this interesting save function. So actually, if I call just save as a function, okay, I'll need to call MLJ save to save the model. So you can see it's not exported, and we are just taking all the things that we've gone through. So binding the model to the data, then putting it into the tuning and saving this as a machine abstraction. We're just saving all this to the forest MLJ. So this is just a 36 megabyte file. So maybe not the smallest, also not the largest, that can be used, deployed on some other computer, even if I close the session. So I can use a machine and the name of the file to load it. And you can see this is just as I would train another model. And if I run predict, I just reconstructed the random forest I trained a second ago from the file. So yeah, this is the wrap up of the model deployment. As I said, you will have a continuation of this. You will see what can happen with the say saved and loaded model on the day 4. But I think for today we have covered MLJ, so training, evaluation, hyperparameter tuning, also pre-processing at the beginning, and a lot of let's say machine learning process to start with. So I think that's all from my side, and thank you for listening, and we'll close the session.